Hi guys, welcome back. So in this video, we'll be treating this question. This question was brought from UTME past question 1995, question 1. And the question goes thus: which of the following is the dimension of pressure? And you have your options. Now I've made a short video on how to answer the best way to answer this to answer dimension questions. So I'll drop in the link up somewhere so you can visit it in case you don't understand this question. But I'm very sure that at the end of this video you understand how to solve questions on dimensions. So according to the video, the first thing I said you should do, there are different approaches to different questions. Now for dimension, the first thing you should do is to identify the quantity that you are being asked to get the dimension. Now in this case, it is what? It is pressure. Pressure. Not pressure. Yeah, pressure. It's pressure. Now, after identifying the quantity, the next thing you do is write out the formula for calculating the quantity. So now I know that most quantities tend to have more than one formula for calculating them. For example, now pressure. The formula for calculating pressure are like three or so. The first one is what? Force over area. The second one is rho GH. Rho there is density. But then since it's just dimension, now you're trying to calculate, and you don't have enough time. Just go straight to the point. Use the simplest formula that you can remember. So the formula for calculating pressure is what? Force over area. So now with this now, then I said in that video that you go ahead after writing out the formula, you go ahead to break down every quantity in that formula to their simplest form. So force is still too big. The force is big. The force is heavy. So you break force down again. Now calculating force is what? Mass times acceleration. So now basically you break each formula, you break the quantity within the formula down to their simplest bit. Now for example, now for this force, now use mass and acceleration. Now dimension is basically you trying to represent a particular quantity with some alphabet that represent fundamental quantities. And we know we have several fundamental quantities: mass, length, temperature, time, electric current, amount of substance, luminous intensity. And each of these quantities have their alphabetical representation. For example, mass is what? M. Length is L. Time is T. Temperature is theta. Amount of substance A. Electric current. Now there is a controversy between electric current being high or A. But in most cases they use high. And amount of substance is A. Although you hardly have to calculate dimension of the amount of substance. And luminous intensity, you hardly have any reason to do that too, but that would be I think it can also be I or C between all those, but you hardly have any reason to use candela, to use luminous intensity, amount of substance in calculating dimensions. It's usually mass, length, time, temperature, and electric current. It does those. Okay, so now after breaking down this quantity now into this, mass is a fundamental quantity, so you leave it. But acceleration is not a fundamental quantity. So you go ahead to break it down again. So acceleration is what one of our acceleration? Change in velocity over time, over change in time. Now, velocity, time is what? A fundamental quantity, so we leave it as that. Velocity is not a fundamental quantity, so we go ahead to break down velocity down. So velocity is what? Change in displacement over time, change in time. So now, displacement is a fundamental quantity. It's just like a different name for it. In the phenomenon also that displacement represent is what is length. Length is fundamental quantity. And your time is also what a fundamental quantity. Now after we break it, so we are still left with area. So formula of everything area is what length times breadth. As I said before, displacement, distance, breadth, width, they're just different names for length. So this is also length as well. So you have LL. So you leave it as that. So now what you are going to do now is you are going to work your way back. Let's start from here. From here, you work your way back to this, you work your way back to this. Till you get back here. From here, you work your way back as well. So what I mean is that now for displacement, the unit is what length. So your answer is what L over time is what T. So your answer will be your the dimension of let's say in this case what L T is to power 1 minus 1. Then you go ahead to first you start in what you already calculated here, LT minus 1 all over T. So you also get what LT minus 2. Then you come back here. Your mass is what M times what LT minus 2. So you're going to get what MLT minus 2. So we've calculated for force, we've gotten for force. Now you go for area, that will be what L times L, that will be what L squared. So what you're going to do is now come to this formula, starting all these things we've calculated, MLT minus 2 all over L squared. When you do the math, you're going to have what ML1, anytime you have division, this is why you subtract minus 2, T minus 2. So it will be what? Pressure. The dimension of pressure will be what? ML minus 1 T is power minus 2. So that'll be your answer. I hope you understand that. I hope you understand this. If you have any other questions, you can drop it down in the comment section below and I'll make sure to make a video explaining the question and breaking them down so you understand it very well. So see you guys in my next video.